My name is Avinash and today I am talking about single sign-on. Before jumping into the topic, let us consider one situation here. Let's say we are an employee working in a big MNC. In MNC, there will be an application for everything. Let's say you want to fill your timesheets, you have to open that application and fill it, and you want to apply leave, you have to go to the application and fill it. So the user has to remember multiple passwords and usernames for multiple applications here. That's kind of crazy if the number of applications are big. So in order to solve this, the single sign-on concept will help you a lot. What is single sign-on? It's kind of a textbook definition here. Basically, single sign-on is nothing but using single set of username and password. You can log into multiple applications, and with that same session, it should be in the same session. How SSO implemented by different companies. Facebook has its own protocol, Facebook Connect, and Google uses the open source SAML. And like enterprises applications, they will use CAS or SAML. Today I am going to concentrate on CAS and SAML. How SSO is different from the OAuth. Since you can say OAuth is also an protocol for using signing in, but OAuth is basically an authorization protocol. SSO is for authentication. In OAuth, what happens is, if you let's say in Flipkart, if you log in with the Facebook, you will go to the Facebook page, and where the Facebook will authenticate you, not the Flipkart app. And Facebook will give you an access token to that Flipkart app, and Flipkart can securely access the resources using that access token. So authorization and authentication will be done by the Facebook, not with the Flipkart app. But in SSO, authentication will be done by our server. Let's jump into central authentication service. It's one of the basic protocols when single sign-on concept came into the picture. First protocol was this. Most of you have studied the Kerberos authentication protocol in your graduation. It's kind of replica of it, but slight modifications here. It's a ticket-based protocol developed by the Yale University. In this protocol, there will be these parties will be involved, where client is nothing but end user or the web browser we are trying to access the application, and CAS client is nothing but in the application we need to configure where it can contact with the server. That configuration whole thing will be handled by the CAS client. Server is nothing but where the authentication really happens. The server has to authenticate us. Service is the application we are trying to access. This is the flow diagram. I know most of it won't understand this, so let me explain. It is clumsy. So let's say I'm trying to access one application here from the web browser. When I'm trying to go to that URL, it will check whether I have a session with this user or not. If it is not there, it will redirect to the central authentication service server, where the server will check whether I have a session with this browser or not. If it is not there, then it will present the user login page, where the user has to enter his credentials. Once he was authenticated, the server will send one cookie. In that cookie, it will contain session key, ticket generation ticket, and service ticket. This information will be present in that browser, and the browser will store that cookie, and it will send the only service ticket to the application. Hey, I got this ticket from the server, can you please validate it? So application will say, yeah, I got the ticket. Let's say whether it's correct ticket or not, I don't believe you. I'll go to the server and will ask whether it is correct or not. So it will again send the service ticket to the server and ask, is that ticket is correct or not? Again, the server will use the ticket validator here, and yes, it's a correct ticket, then you can give access to the user. Once the server validates the ticket, the application will create a session here and will communicate over the user with that session only. That's the first time. When you're trying to access same application for the second time within the same session, it will talk over the session generated by the application. It won't go to the server. That's the first application. Let's say I want to open the second application in the same domain with the same session in the same session. Now the browser we don't have a service ticket for the application, right? So it will send the ticket generation ticket to the server. Server will say, yes, I know this user, he was already authenticated, so I'll provide you a service ticket for this application also. Same continues, the application flow continues for the second application. That's how the CAS authentication mechanism works. These are the CAS URIs, generally an HTTP protocol based approach. So server will define some URIs for everything. So the client has to hit the URIs for authentication process. Let's say for /login for logging the user, logout for destroying the CAS session, validate, service validate. These are all for URS the client has to call during the authentication flow. I'll play a video where I developed 3 apps. One acts as an authentication service and 2 are clients. Okay. Django Auth is our server, authentication server. So I'm running the server, and shop is like shopping app. Let's say I'm running it on different port, and billing app 802 port. So when I go there and trying to access the application 1, he will directly redirected to this server because he was not authenticated, where I'll need to enter my credentials, but I'll try to open the second app also, so you can compare the difference, what will happen if a user was authenticated. Even he also redirected to the, so now I'll open my server and will give permissions to the user so he can access the applications. Already created one admin super user in the Django. I'll log in with the credentials. And give that user necessary permissions to create. For demo sake, I just added all the permissions. Now I'll try to log in with those credentials, so I'll get that access. As you can see, once I'm authenticated, I'm redirect to the index page of the application. From the URL, you can notice that. And when I try to go to the application 2 and access the login page of the application 2 again, it will automatically authenticate you and redirect to the application index page. That's how. Yeah, that's a short demo. I'll try to explain what is the code I just written there. Okay. I have used 2 packages there, Python packages. One is CAS for server configuration, and another one is CAS ng for the client configuration. So we need to run migrations after installing the package in the server, and then we have to do our configuration here. As you can see in the install apps, we need to import our CAS app that will act as a client server here, that will take care of the server configuration. And CAS services, we need to define applications which can access this server. So you can see the service. You can specify the URL of the application 1, and after the callback, you can specify what is the attributes I need to send to the application when he is authenticated. Currently, I am asking for the username attributes. We can say what are the permissions he has. We can define that here also. And logout hello. These are all other configuration you have to do. And URL patterns. As I said earlier, CAS is an URL based protocol. This cas.url is nothing but the URLs I have showed us before. That's all. Server configuration we have to do. In the client configuration, CAS ng is another package that will take care of the CAS client information. And in the authentication backends, we need to add CAS ng backends because authentication we don't need to use the Django backends for authentication. We are trying to use the CAS ng backends. And URLs, these are our specific URLs. We can define as URL you want, but I just added these. And we have to define view, which view we want to show after the authentication and all. These are the URL patterns, and that's all. As you can see, multiple round trips are involved in the single authentication itself, right? It will be a overhead for the client, and if the network is too slow, then authentication will take a lot of time because a lot of round trips happening between the client and server. So in order to mitigate this, they come up with the SAML 2.0. Generally, SAML is not in a protocol. It's a security assertion markup language, just like an XML where you have to assert each and everything. And it helpful for log. I mean, just SSO implementation can be done using SAML also. SS flow using SAML involves 3 parties here, where identity provider is nothing but an authentication server, service provider is our application, user agent is nothing but our web browser. SS flow using SAML. First of all, client and server will agree on one certificate, one digitally signed certificate. So client will know who is the server, and server will also know who are the clients. So when authentication request comes to the server, it digitally signs the service ticket and send back to the browser. So when the browser submits the service ticket to the application will definitely know, because of the digital signature signed by the server. It will always know, yes, this is only the correct ticket. So it won't send the service ticket back to the server and wait for the response. That's how it will reduce one round trip here. I don't give any demo for the SAML because it's a bit complex here. We have to define our SAML accession languages between server and clients. Generally, there are a lot of identity providers here. As you have said, identity provider. You can implement own, but it will be a bit complex. In market, there are a lot of service identity providers. One is Okta, one is OneLogin, and Google also provides you an identity provider. Pros and cons of SSO. Definitely, SSO helps you to reduce the password fatigue because we don't need to remember multiple passwords. So it will definitely no need, and simplifies the user and password management. If you forgot one password, in MNCs generally, if you forgot one password, you need to raise a request for the IT desk team. They have to go through a lot of flow to generate the tickets. But so it will be painful for them for generating multiple tickets because for a single user. So if you say you have only one password and one user for all the applications, it will reduce the burden on them. So that's one pro. And provides detailed user access reporting. Since our server is only the single authentication source, you can easily log all the user activities, authentication user activities easily. Cons. SSO gives you keys to the castle. Since it's a single user set of credentials, once any hacker got to know your credentials, he can access all the applications without any drop. So SSO don't work when your identity provider is done. Your server has to be always up. It should not be down. If it is down, no user can access any application in your domain. SSO takes a little bit of investment to set up. So we need to configure our services and clients. And if you want to use SAML, you need to take some from permissions from the Google and all. So it will take a lot of time. Thank you.